All right, so for today, what I want to start with is a little bit of the idea that I started in the last lesson, where I said to you that in order to deal with trig graphs, you need to be able to solve about what a trig equation is. A trig equation is just solving for an intersection point between two graphs. And the two graphs in this case, and I showed this in the last lesson, it would have been y equals sine x and y equals 0.2. And if we wanted to solve for the intersection points between these two graphs, we would just make them equal to each other. Now, I just want to get a thumbs up if you understand the idea that solving a trig equation can be interpreted kind of like an intersection point as well. Give me a thumbs up and give me a thumbs down if the idea of an intersection point solving a trig equation makes no idea. Give me a thumbs down. Okay. So in case I see most students are telling me that things are okay, but just to kind of show you what I mean, on the left-hand side here, we have a trig graph. Okay, so let's see if I can bring that across. There we go. It's the graph of y equals sine x. And if you think of solving this equation, you want to know where sine x is equal to 0.2. And so if you imagine y equals 0.2, that's just going to be this line over here. And so two of the solutions to this equation, there's going to be one over here and there's going to be one over here. And so obviously we still need a method to find those two solutions. But if you make two graphs equal to each other, you find the intersection points. And we did that in algebraic graphs. And I just wanted to bring that connection because this unit is really a lot about intersection points and graphing interpretation. But let's do another one just to get a feel for it. So if we look at the next question, which is B, we have to solve the equation cos of x equals, so I'll even draw it bigger, cos of x equals minus 0.3. Now, in terms of using an algebraic method, what I generally say to you is it's a three-step process. And the first thing we do is we find the reference angle. But when we find the reference angle, we have to do something in particular. And I'd love somebody from the audience, from the classroom to tell me, how do I find the reference angle for a trig equation? And what are some of the important things I have to remember? So pop your hand up if you can give me a top tip for this thing. So pop your hand up. Otherwise, also you can put it in the chat. Tegovatso said you must use shift cos, or what we call inverse cos. You're quite right. So the one thing you have to do, and maybe we can even put this, let me actually put the calculator on the screen so that you can see it. So we'll go stop share, and then I'll go share screen, and then I'm going to go desktop 1. And Lebo, just to confirm, you can see the calculator that's hanging out on the left-hand side. Okay, cool. So now what I want to do is I want some tips about how I'm going to go about this. Tegovatso has given me a nice tip. Don't substitute the negative. Aha, yes. Okay, so when we are finding the reference angle, what we want to do is we actually want to go shift cos and ignore the negative. So what it looks like on your calculator is the reference angle is going to look like that. So let's type it in our calculators to see this. So we go shift cos, and I'm ignoring the negative. And the reason I'm ignoring the negative is that I will take that into account when I talk about quadrants. And so what I get as my reference angle is 72.54 degrees. Now that is not the answer to this trig equation. The answer to this trig equation has to do with getting the 72.54 in the right place. And the way we do that is how? How do we now figure out, in fact, maybe I should even, let me just move this down if I can. How do we think, let's visualize this for a second. Maybe I'm trying to get too much on the screen right now, but if we look at the cos graph here, on the right-hand side, we've got a cos graph, and the equation that we're trying to solve is this one. If we wanted to visualize where the solution happened, it's going to be where cos x is equal to minus 0.3, or where the cos graph cuts negative 0.3. And so if we were visualizing it, I think I will have two solutions, but the two solutions are not between 0 and 90. They're actually further on. So there must be something more to finding out what these exact numbers are. Who can tell me what the second step is in solving this trig equation? Okay, so what we ask ourselves, and Watobe has helped us out again, is on what quadrants is cos going to be negative? Now, there's something called the cast diagram. Don't know if you remember that. And the cast diagram tells us that cos is positive here and here, and cos is negative in these two quadrants. So give me a thumbs up if you understand that cos needs to be negative in quadrants 2 and 3. I want to see, if you don't understand, thumbs down, because I don't want to lose you on this journey. It's an important, if you get this now, like trig equations are going to be your friend. Okay, now, in quadrant 2, the answer will always be 180 minus the reference angle. And in quadrant 3, the answer will always be 180 plus the reference angle. So when we get to step 3, what we're now going to do is we're going to try and incorporate this so that we can get our answers that match the drawing on the right-hand side here. Oh, my mouse is being difficult. So let's try and do this. But you know what, before I do it, I want you to try and calculate, or some of you can maybe try and work it out for me. So we know step 1 was get the reference angle. We know step 2 was knowing what quadrants. I want to know, what is the answer to this equation going to be in quadrant 2, and what is the answer going to be in quadrant 3? And then I want you to put it in the chat here. X is going to be equal to for that. X is going to be equal to for that. Sorry, this is going to be minus. So what are we going to get for quadrant 2's answer? It seems like we're going to get about a 107.46. And in quadrant 3, we're going to get 252.54. Now, what that's telling me is that the intersection point, so the answers are this, but it also tells us the intersection point for this graph between negative 0.3 and cos x. So this is going to be the 107.46 answer, and this is going to be the 252.54 answer. And so this makes me happy because I know that it fits the graph. The last thing I can do, just to make sure that I am checking out here, is if I type the cos of 107, so 107.46, I should get very close to negative 0.3. And there we go. So indeed, I do have an answer to my trig equation. Okay, cool. Give me a thumbs up if that makes sense. Oh yes, Ayando said, don't forget to add the 360 times k. All right. If it is, the question says, find me the general solution, then you would have to add the 360 times k part. But because this is only asking, and I didn't really make a big deal of this, it's only asking for answers between 0 and 360, we don't have to do, it doesn't say give a general solution. So for now, we're okay for doing this one. Okay, now I want you to do the next one by yourself. The next one is going to be, we're going to do this one. So I want you to solve for me the trig equation sine x is minus 0.9. So you're going to solve for me for answers between 0 and 360. I don't need the general solution. I just need the two answers in 0 to 360. And then while you're working on that, if any other students have questions about this three-step method or about the graphing interpretation, please let me know. I would love to assist. You should get a reference angle of 64.16. But we know that that's not going to be the answer to the equation. We can almost see it visually. If we look at the graph, where does sine x cut negative 0.9? It cuts it basically down here. So we're expecting the answer to be greater than 180 and between 180 and 360. And the way we get it is by saying, where is sine negative? And sine is negative in this quadrant and this quadrant. So what do we have in this quadrant? We have 180 plus the reference angle. And then for this answer, we have 360 minus the reference angle. Indeed, Tandeka, you are on the right track, but can you get me the answer in quadrant 3 and 4? That's what I want to know. What are my answers going to be? Mesh says, and I think I agree, 244.16 is going to be the answer in quadrant 3. And Mbasa agrees. That's fantastic. Morgan, 295.84. I agree. So the question has been asked in the chat. Do we have to round the answer for the reference angle? Yes, it's generally a good idea to round your answer for the reference angle to 2 decimal places. Generally, that's the convention that I've seen. Okay, so if we look at the graph, this makes sense to me because I can see the one answer up here. This is going to be the 244 one. And over here, this is going to be the 295 one over here. And so the answer to that is going to be that one there. Okay, let's do one more before we move on, because you guys are hitting it out the park. The last one we're going to do is, what is the answer to tan of x equals 7 in the domain 0 to 360 using this 3-step method? So we've done a sine, we've done a cos. Let's not leave tan out. Find me the answer to this question. Find me the answer to when does tan of x equals 7 in the domain 0 to 360. I'll leave the other answer for a bit so you can use it to help you, and then I'm going to take it down. You can do it. You can do it. Let me turn my light on while we do this. Yay. So I suppose it would be nice, since we've been doing more graphing in this topic, I should probably show you the intersection point of tan x and 7, which will be the answer to this trig equation. So let me bring up a tan graph so you can see that. Let's see if we can get it here. There we go. Make this one smaller. Get rid of this. Move that again. So when I think of tan of x equals 7, I guess it's going to be somewhere up here. And it's probably going to cut the graph. I mean, I'm kind of extending this, because remember, this goes up forever. So it feels like the answers are going to be here and here, roughly speaking. So let's see how the method works. What is my reference angle on the people of the land? What 81.87 seems to be our unanimous thing. And where is tan positive? Tan is positive in quadrant 1 and quadrant 3. So in this angle, it's just the reference angle as you've calculated. And this one is 180 plus. And then the answers in quadrant 1 and quadrant 3 should be 81.87, or they should be what? What's the third one? So it should be 180 plus 81.87. what's that going to give us? I guess I could use my calculator. Huh? I could just say 180 plus 81.87. I hit the SD, 261.87. And so that would be the second answer. There's the 261. And then over here would be the approximately 81. Okay, let's have a quick little class feedback vote. Thumbs up if you're following how to solve trig, basic trig equations, and how to see them as also as intersection points between a trig graph and a constant straight line. Well, that is fantastic news. Now, if you're unsure, don't worry. We're going to have a chance to come back to that. And remember, you can also rewatch the video at a later stage. But let's go on to before the break, we're just going to get a bit of a warm-up going on a different type of old exam question. So let's have a look at this question over here. And then we're going to take a break. We're not going to do the whole question now. We're just going to have a look at the first bit. So this is an old exam question. And what we see is we first ask ourselves, what are the characters involved? We have a sine graph, which I'll call F, and it's in yellow. And then we have a G graph in green, which is a tan graph. Now, in the last lesson, we spoke a little bit about changing basic trig graphs. And I want to know in the chat, what does this A value change for the sine graph? And what does the B value change for the tan graph? So first of all, tell me, do you know what they're changing for those graphs? Put it in the chat. Morgan has suggested that amplitude, and so is Sino, Tegavazzo, so we're pretty confident that this A affects the amplitude. So that stretches the sine graph up and down more than it normally would. And then, so that's amplitude. But then what does the B change for the tan graph? Okay, it's going to change the period of the graph. Okay, here's our first question. We have to determine what are the values of A and B. And the way we're going to do this is we're going to think about, let's say, the yellow graph. What does sine normally go up to and down to? And what does it go up and down to in this case? And how can that help me figure out the value of A? So I want someone to put their hand up and tell me what the answer to A is and how did they know, how did they figure it out? So the one thing is the answer. The other one is, how did they know? What did they look at? What is the number in front of the sine graph? This is okay. So let's unmute you. Can you hear me? Hey, how's it going? How did you know what A was?
I knew how A was because the normal amplitude of the sine graph is normally 1 and -1. So in this graph, the sine graph goes up to 2 and down to -2.
Okay, so you saw the stretching that was happening, and you then knew that because it's going up to 2, you get that.
Yes, sir.
Perfect. Thank you so much. That was awesome. All right. Now, what about B? B has to do with the tan graph. So I guess we should take away our focus from the yellow one and now look at the tan graph. Now, this tan graph, what's different about this tan graph? There's something different to normal. What do we have as reference points? When you think of a normal tan graph, where are its asymptotes normally? Because I'm seeing, I ignore this line, but I'm seeing this 180 over here, and that looks like it cuts up the tan graph into that side and that side. So normally, Eunice has said that normally it's at 90 and 270, and now it feels like it's been pushed outwards. Now, what do we normally do when we want to find the period of the graph? Well, we go, whatever the old period of the graph was. So what's the old period of the tan graph? It's 180. And we divide it by the number in front of the x. In this case, it's b. In the last lesson, I was calling it k. But normally we take the old period, divide it by whatever the number is in front there, and we get the new period. Now, what is the period going to be for this tan graph? If you look, how long does it take to fit a whole tan graph in? Normally, you can fit a whole tan graph in 180. How much space do you need along the x-axis to fit this tan graph in? It looks to me like it starts here, and that's the first half. And then the second half goes like that. So it looks to me like I can fit the top half here and the bottom half here, and it fits in 360 degrees. So it feels like the period of this tan graph has changed from 180 to 360. Give me a thumbs up if you can recognize that the period of the new tan graph, this one that we're showing you here, is 360. Another way to maybe see it would be to say, look, if it carried on, what would it look like? It would look like that. And where would the next asymptote be? I think the next asymptote would be at 540. Okay, so now what you have to help me with is, I go, what's the old period divided by b? And that's going to give me the new period. I want you to work out what b is for me. What is b going to be equal to? How would we get the b by itself? I guess I would take the b to this side. So then I get 360. Oh, I'd get, let me do this again. So I would get 180 divided by 360 equals b, because I'd bring this to this side. And that would mean that b is a half. Okay, and so that makes sense, because if you imagine this graph's period has been increased, because when you divide by a half, the number gets bigger. Okay, that was a little bit of a sneaky one there. I think what we need to do now is have a bit of a brain break. So please, will you stand up, turn your cameras on, and we are going to do some stretching so that our brains, you've worked hard. You've done trig equations and you've done some basic interpretation, and we will continue with that after the break. But what we first need to do is just take care of our bodies. So take a moment to stretch up to the sky, and then look off into the distance so that your eyes get a break. So look at a point on the other side of the room, or if you're lucky enough to have a window nearby, look out the window, stretch out your arms, and there we go. Okay. All right, then your eyes have had a break. Let's shake out your arms, make them nice and loose, and shake out your legs. There we go. And let's stretch our necks, because they get a bit of a workout when we're squinting close to the screen. So do that. Do some triceps. Okay. Stretch that out.
On this action, guys.
There we go. Okay, shake it out again. And then let's do shoulder rolls back. So 5 of them, and shoulder rolls forward. And then let's just do a bit of twisting. So a little bit of light rotation to start with. As you warm up, you can go further. Okay, and then shake it out one more time. And then let's do some cardio, and let's do air skipping, because I think we did the other one last time. So we'll do 20 air skips in 3, 2, 1, 2, 3, 4, 5, 10, 11, 16, 17, 18, 19, 20. And there we go. I hope that your body feels a bit less stressed than before. And then let us go to a brain break. Tell me what a cat plus a lion plus a chicken is equal to. Unravel the mysteries of the Animal Farm here. Has anybody read the book Animal Farm? It's a good one. It's a good one.
I've heard of it, but I haven't read it.
It's a classic. It's a very deep book. On one level, it's very easy to read. On another level, it is a cautionary tale about humanity's tendencies. So I would definitely recommend it.
So it's not actually about animals.
Well, it is on one level, but on another level, it's about how people treat each other. So it's like one of those clever books where it's like, it's sort of a metaphor for how people treat each other. So I won't say more than that, but careful there, Annie. Don't go to. I mean, we don't want
go too hard, Annie.
chiropractic crack levels going on here. It's just a light little stretch so our brains take a moment.
Yeah, otherwise parents are going to say Watobe's a health hazard.
Yeah. Okay, so we have 20, 20, 20. Then we have 20. So what is this going to be? I guess we need 20. No, we need 64 minus 20 to give us 44. So then, or another way of saying it is we could add 20 to both sides, and then we get 2 lions give us 64. So 1 lion must give us 32. Because the minus 20. So now we need to know what a chicken is worth. And chicken is getting more expensive, but right here, I think it's a fixed one here. So that is going to be 30. Because of that. What is my final answer going to be? So 1 kitten is 20, 1 lion is 32, 1 chicken is 30. And that today's brain puzzle teaser thing, 62, 82, 82.
Nicely done.
There we go. There we go. All right. And I see in the chat there, Kutwano, Mesh, Tandeka, Simpiwe. Okay, so lots of students have got that, and I hope you enjoyed our little puzzle there. Okay, let's get back to this question. I'm going to leave, we've got limited time, so I'm going to focus on the ones that I think are the most useful right now. Now, what I want to know in terms of this question here, in fact, let's go and look at another one that's similar to the one we just did. We'll come back to those other interpretation questions if we have time. Let's look at this question here, because I want to give you a chance to fly a bit solo in this case. So all I'm going to say to you is that there is one function, and the function f, which is that one, and there's another function, a sine function that has a change. What I want you to try and do for me is work out what the value of P and Q are using the graph that you have above and the what you've learned in the previous lessons. So I want to give you a little bit of time just to try and work that out. If you have a question, you can pop it in the chat, but otherwise over to you guys to work this out.
Go for it, guys. Go for gold.
Go for gold, indeed. Maybe good to ask yourself, what do you think the Q actually does? Maybe someone who's feeling generous can pop that in the chat. What does the Q do to the original cos graph? And what does the P do to the original sine graph? Okay, so Masejo has said that the Q shifts the graph up or down. So let's maybe even highlight the F, just so we keep our eyes on the prize here. So what do we think the value of Q is going to be? Where is the cos graph normally between? That's the question. Where is the cos graph normally between? From what I remember, the cos graph is normally between 1 and -1. So the Q must be affecting the graph in some way. What do you think is happening? What do you think my Q value is going to be? Who wants to raise their hand and tell me? I can feel there's someone out there who knows it. I can use my spidey sense. Aha, Morgan has suggested a half. Morgan, I think you're on the right track, but I want to ask you, what type of a half is that? Because it matters. Is it a positive half? Is it a negative half? Mesh agrees it's a half. Now what I want to suggest is if it was positive a half, then the whole graph would have had to move up to here. But what I see is that actually the whole graph seems to move down a half. So the correct answer is Q is minus a half, because the whole graph normally is between here and here. But because of this Q value, the whole graph ends up being between here and here. And you can literally see, like, if you compare the red to the green, it's moved down by a half. Okay, so we know Q is minus a half. Now we want to talk about P. And someone in the chat, if I scroll up, maybe I can see, has said that what Q does, shifts up, and then Mesh has said P will shift the graph horizontally, left or right, or depending on if P is positive or negative. So let me start by asking you, what do you think has happened? Has the sine graph, or what I will call the green graph, Has it shifted to the left or has it shifted to the right? Let me see if I can find and draw it for you. Look how helpful it is when I put a bit of color on my graph. It's like my brain is so thankful that I just took the time to tell it which one to focus on. So I would recommend doing that in class as well. So do we think this sine graph has shifted to the left or it's shifted to the right? If we compare it to what normally happens. The sine graph normally starts over here, from what I remember, and then it goes up to 90. And then it would come down to 180. Excuse my little drawing there. But that's what I remember. So then it feels to me like it's gone that way, or it shifted to the left. And in order to go to the left, I actually have to add to the right in my actual, the p-value will be positive in order to cause the graph to shift to the left. So the question now is, what is that p-value going to be? Who wants to have a crack at figuring out what that p-value is going to be? Yeah, I like what I'm seeing there. P is going to have to be equal to 30 degrees. So it's going to be x plus 30. So if I was rewriting this in terms of what's really happening, we've got the graph of cos x, which is minus a half. And then we've got the graph of g of x equals sine x plus 30. And that's finding the P and Q values, which is a little bit tricky. But my hope was by going slowly through that, you got an idea of the type of question. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't. Okay. Now, the next question. Determine the values of x in the given interval where f is greater than g of x. So we want to know for what values of x. Now, where are the x values? The x values are all along here, right? Those are the x values. And this is saying, when is the graph f above the graph g? So I want to know for which x values is maybe I should use the different colors so that you can actually see it. So originally I said that f was the yellow graph. And then the green graph was this one. And I want to know for what x values, so for what x values is the f graph above the green graph? Now, it looks to me on this side, the green graph is above the yellow graph. So that's not going to be an answer on this side, right? Because we want to know when is the f graph above the green graph. For what pink values is the yellow above the green? Now, I know it sounds like a bit of a mouthful, but see if you can figure that out from the drawing and pop your answer in the chat. What are the important points I need to look at? It feels like this is an important point because at that point, they're equal to each other. And then at this point over here, this is also an important point because they're also equal to each other over there. And I'm trying to describe for which x values or which of the pink bits is the f graph above the green graph. And it feels like it's between those two dots. So how would I describe this region in mathematics? What tool do I have to help me describe a region on a number line? We could say x is between two values. So I think, what's the value over here? This is minus 120. So x must be greater than minus 120. Oh, let me bring that back. X must be greater than what minus 120 because the yellow graph is above. And then at some point, the point over here, they're equal. What's that point there? I think that x is 0 at that point. And so if x is between -120 and 0, f of x will be greater than g of x. Take a moment to just look at that and see if you understand it. Now, that is a very tricky question, so I don't want to spend too long on it, but I just wanted to give you an idea. If it says, where is f greater than g, you're saying, where is the yellow graph above the green graph? It looks to me that the yellow graph goes above the green graph at -120, and it stays above it until it gets to 0, and then it dives down here. Now, you can be honest about this. I know this would have confused a couple of you, but thumbs up if you follow my argument, thumbs down if you feel completely lost. So, oh, okay. So, Simpiwe, minus 60 to -30 is included. So it's not wrong. This is fine. Okay. This is included, but what I'm saying is that this bit over here and this bit over here are included. Because can you see the yellow graph is above the green graph over here? It's still above over here. And then at this point, the green graph overtakes it. Okay. Can I suggest, I can see that a lot of you are confused by that, so don't stress. I will come back to that at a later stage. But if you need to, just rewatch that explanation again. And I promise with time, it will make more sense. But let's do one more question for today. Have we got time? We've got time. Let's do this one. And then we can call it quits for today. Okay, now, first of all, there's a labeling mistake in this question. So let's just make sure we identify the correct function as the correct function. So we are given two graphs. The one is the g of x, and that's called sine x plus p. And we have the amplitude changed, and we have a vertical shift. So that's not immediately obvious which one that is. And then we have a cos one that also has, that is a period change. And they're shown in the domain. So which one do we think it is? I think this one is the yellow one, is the sine graph, which I will give to you because of limited time. And then I think the green one is the cos graph up here. Okay, so that's the cos graph. Can you find for me, let's focus on the cos graph to start with. Can you find me the value of B and the value of Q? Find for me the value of B and the value of Q. Notice that B would be an amplitude change for the cos graph, and Q in this case would change the period of the cos graph. Might be helpful to have some like so I think lots of students are seeing the amplitude of the cos graph is 3. So B is 3. What is Q going to be? Aha, have I labeled it the wrong way around here? Let's have a look. Cos graph? No, I'm pretty, or let me have a look. Yeah.
No, I just mean, I don't see the need to cancel the formulas.
Okay.
It looks to me that it's correctly labeled.
Correct. Oh, okay. Yes, I think the problem is the F going to sine. Oh, you're right. That's the problem. Cool. No, it's fine. I get you. There is still a different problem, but we'll won't worry about that one right now. Cool. What do you think the Q is going to be? I think that this graph hasn't actually been shifted up or down at all. So what would Q have to be? Oh, sorry. Q is not for shifting up or down in this case. Q has got to do with the period. So the period of this graph, or what's the period of the cos graph normally? It's normally 360. And so I would divide by Q. Now, what is the period of this cos graph? I think it goes 180, 360. So this is going to be 720. So what is Q going to be now? Who feels like there? Yeah. It's going to be 360 divided by 720. Like if I bring this across and I bring this back here, I'm going to get a half. Okay, last little bit for today. In fact, you know what, guys? We've actually run out of time. So let me rather, instead of rushing it, let's just pause at that stage. We've done a lot today, and I think if we rush, it's going to get in the way of you actually kind of getting into your quiz tonight. So, Level, can I ask you to put the link to the quiz in the chat? And then I just want to think about what we did today. So we started today by going over how to solve trig equations. We then started to look at how to interpret trig. If we're given a trig graph, how do we work out the missing unknowns? And so we had a bit of practice with that today. And we even did some of those more difficult interpretation f of x less than g of x questions.